So let's begin with the factors, the leaving group. You should be always aware that you always need good leaving groups. It makes no sense having bad leaving groups because the reaction is not going to give you a good yield, or again, the leaving group will not leave. So obviously, you see how this would be the fastest reaction, fastest rate, simply because I is the best leaving group. So if you put the reagents with 3 different test tubes, RCL, RBR, RI, you would obviously pick the RI because that would give you the fastest rate. Of course, then the BR, then the CL. Very well. The alkyl halide, the substrate. E2 proceeds fastest with the most substituted alkyl halides. That's the key here. So remember with SN2, it was the methyl the fastest, then the primary all the way to the tertiary, which of course we said there's no reaction with SN2. But with E2, it's the reverse now. You want to have more substituted alkyl halide because more substituted alkyl halides provide the most stable alkene. So in the transition state, the double bond is partially formed, as you see here. So the increasing stability of the double bond with the alkyl substituent stabilizes the transition state. So the transition state here is stabilized due to having more alkyl substituents. They simply, again, lend electron density. They provide electron density, as we say over here, increasing the number of electron donating groups on the carbon atom to accept electron density, make the alkene more stable. So let's give you an example here. What you have is you have an alkyl halide, and you have a base. This is your base. So let's start putting the lone pairs on there. And of course, this is a primary alkyl halide. This one, let's see why is it the primary. I'm going to delete this after I mark them. If you look at this carbon, it's attached to one other carbon. So that's why it's primary. So this is your alpha carbon. While here, you actually have a tertiary alkyl halide. I'm just going to write tertiary, 3 plus, you know that I'm talking about alkyl halide. I need more space. So here's your alpha. This carbon is attached to 3 other carbons. That's why it's tertiary. Very well. So let's begin by identifying the beta hydrogens. So obviously, if you have an alpha carbon, this would be your beta carbon right here. So this, of course, would be your beta hydrogen. And of course, it would be here as well. Once again, the other ones, of course, in here have beta hydrogens, but we choose to focus on one so you can see the reaction taking place. So I'm going to delete this again for space issue. Okay, so this is what would happen. The reaction would proceed this way. It's all one step. The lone pair would attack the beta hydrogen. Of course, you could have chosen the one on the bottom as well. The electrons between the hydrogen and the carbon shift and make a double bond between the alpha carbon and the beta carbon. And of course, the lone pair then leaves. So keep track of this, and you would get the following product. Begin with this right here, CH2, CH3, CH2. Okay, so that's this group. That's this H. Okay, let me make this a little bit more clear. Then you have a double bond. And then CH and CH. Okay, I'm going to just rewrite it like this, redraw it like this. Plus, of course, HOR. But we don't care about the base here. So here's your product. Once again, I will mark the alpha carbon. It's right there. So you can see it. All right. So if we do this, we would get here a mono-substituted alkene. There's only one R group. If we do this one, here's our beta hydrogen. And the bromine is kicked out. Your product, of course, now would be a CH Okay, I hope you're making sense of this. Here's your alpha carbon. And if you notice here, you have a di-substituted alkene. You have two R groups. Now, if you remember, which one would be more stable? The more R groups, the more stable. So this would be a more stable alkene, and it would give you a faster reaction. This one would be less stable, which obviously would give you a slower reaction. So again, the more substitution you have, the more stable. Here are your R groups. So that one obviously have two R groups.